Alright, here's another video for 3HT about exercise 55. The question's over here, exercise 55. It says a manufacturer puts codes on his product by either coloring a box in a 3x6 grid blue or leaving it blank. See the example on the right. So a couple of these boxes have been colored in blue and some of them have been left blank. And the question is probably how many codes can we make? So the first question is how many codes are possible? Now this exercise is a bit more difficult than the previous ones, but if you know how it works then it's not so hard, but it's very hard to figure it out yourselves, I think. But we have these boxes here, and every box can either be blue or blank, right? So there are 18 boxes in total. So here you have two possibilities, here you have two possibilities, here, etc. So the number of codes you can make is 2 times 2 times 2 times 2 times 2 times 2, and that 18 times. So to write that down shorter, we can write down 2 to the power of 18. So let's type that into our calculator. Let's do that. 2 to the power of 18 is, this is a very big number, 262,144. So 262,144 different codes. That's how many codes you can make using this system. Question B. How many codes are possible where all the boxes along the edges are colored blue? So everything here around the edge must be blue. So we don't really have any choices there. So there it's 1 times 1 times 1 times 1, etc. until you're all around. In the middle we have 1, 2, 3, 4 boxes. Now, those boxes can be blue or blank. Right? So we have, for each of those 4 boxes we have 2 options. So we have 2 to the power of 4, which is 16. So we don't have a lot of different options there. Exercise C. How many codes are possible when all the boxes in the middle row are left blank? So the middle row is this. Those are all blank, so we don't have any options there. So we're only talking about these 6 boxes. They can be blue or blank, and these 6 boxes, they can be blue or blank. That means that there are 12 boxes that can be blue or blank, but the middle ones, they must be blank. So you can add, if you want, you can add times 1 to the power of 6, because for these you don't really have any options. But let's not make it any more complicated than it is. So the answer is just 2 to the power of 12. And 2 to the power of 12 is 4,096 codes. So this was exercise 55. I'm also going to be talking about one of the other exercises, exercise 56. So let's write down 56 over here. In the book we can see that there are 13 girls and 16 boys are in a third year class. 3 students are chosen to organize this class's party. The first student will organize the music, the second the drinks, and the third will organize the snacks. How many possibilities are there when a boy organizes the music and then a girl organizes the drinks, and it doesn't matter who organizes the snacks? I'm going to assume that the same student does not organize multiple things, so they all organize different things. Now there are 13 girls and 16 boys. Let me just write that down over here in case I forget, right? So I can just look at this. So 13 girls and 16 boys. And the question said that a boy must organize the music. So first we have 16 boys and one of them is going to organize the music for us. Then it says a girl organizes the drinks. So times 13, because we have one of those 13 girls that's going to organize the drinks. And it does not matter who organizes the snacks. But like I said, we're going to assume that it's a third person and not one of these. So that means that we still have 15 boys and 12 girls left. So we still have 27 people left that can organize the snacks. Right? Now, if you assumed that it can actually be one of those, then you would have 29 here. Because this question doesn't specify, so I wouldn't use this question on a test, right? I would change it a little bit, right? But if you had times 29, then it's not really that big of a problem now. But his answer is 5,616 possibilities. Alright. Moving on to exercise B. There, the question says that how many possibilities are there when a girl organizes the music and 2 boys organize the drinks and the snacks. So one boy organizes the drinks and one boy organizes the snacks for us. Let's calculate how much that is. Right, so first of all we have a girl that's going to organize the music for us. Then we have one of those boys that's going to organize the drinks. And then we have a different boy, so times 15, and he's going to organize these snacks. So we have 13 times 16 times 15. So we can make 3,120 possibilities here. Moving on to exercise C. There it says, how many possibilities are there when only girls organize the party? So one girl is going to organize the music, then one the drinks, and then one the snacks. That means that first we have one of those 13 girls is going to organize the music, and then you have 12 girls left, and then 11, and then, well, that's it. So let's see, 13 times 12 times 11 is 1,716 different possibilities here. So this was a video about exercise 55 and 56. So thank you very much for watching, and I'll see you next time. Bye bye.